Hello guys, in this video I'll explain you about broadcast variable, what is broadcast variable and when will you use it. Also we'll write Pysaprk code to implement broadcast variable. So how we can use broadcast variable concept to make Pysaprk code, that also we'll see in this video. First we should know what is broadcast variable. So let's start. So if you know broadcast, okay. So if you know map side join is Hive, then it is similar to so what I'm to say map site join in Hive equal to broadcast join in Spark okay. This is the same concept. Map site join in Hive equal to broadcast join in Spark. So what is this broadcast join? Okay, so the concept is if we have a two table, one is big table, big 1 TB data, one is small table 20 MB data, 20 MB data. So this 1 TB table. So first we will load this big table in our Spark cluster. It will try to, so what Spark driver will do, it will try to distribute this 1 TB data in across multiple worker node. But I also want this small table also in my Spark code. So what is the procedure is, we should not load this data. We will directly send this data in our Spark driver, so that we can reduce the data shuffling. Let me draw a diagram. Okay, this is our driver. This is worker node, or in worker node here is a executor ex1. Okay, this is ex2 worker node 2. This is one worker node 3 ex3. Okay, so now we have to listing. We have a two table. One is big table, one is small table. We have to join those two table. So in broadcast join, what we will do, first we will load this big table in our Spark cluster. So Spark will try to distribute that 1 TB table among this worker node 1, worker node 3, worker node 3. Now we have a small table, and the size of the small table is 20 MB. Now what this broadcast join will do, it will try to send this 20 MB data directly. It will send the copy of this 20 MB data directly in this directly to the worker node. Okay, so every worker node will have copy of this 20 MB data. This is a small table. So what will happen? We are not partitioning this 20 MB data across this worker node. So when we will try to join, or we will try to some operation with this two table, there will be less data shuffling. Okay, there will be less data shuffling, and performance job performance will be better. It means the job will complete faster. The job will be faster. Okay. So that is the logic of broadcast. Actually, in this concept, what we are saying, if there is a two table, one is small and one is big. If this small table size is enough to store in this Spark memory, okay, because this small table will store in the worker node memory, okay. So this size of the small table should be less than this worker node memory, okay. So it cannot be that the in worker node we have a, let's say we have a 500 MB memory and we are sending 600 MB small file. No, it is not like that. That the size of the small file should be less than the memory of this worker node, so that it can, this small data can feed into the worker node's memory. So what we are doing here, so we are distributing, we are loading the first, we are loading the big table. So so this driver will try to distribute this big table among this cluster, and then we are directly sending the small table to the each worker node, so that when we'll do join or we'll do some transformation, there will be less data shoveling and better performance. And so that is the broadcast join. And what each broadcast variable, because our focus is broadcast variable. Okay, here what is broadcast variable? So actually we will not send this 20 MB data directly. From this 20 MB data we will create a data structure. Okay, and that data structure will send. So from this data we will create one data structure, and we will send this data structure to every worker node. So that is called broadcast variable. Okay, so broadcast variable is a mutable data structure which which is cached by cache in worker node memory. Okay, so let's say we have this 20 MB dataset, small dataset. From this dataset we are getting one data structure. Okay, from this dataset we are doing something and we are getting one set data structure. We will send this set data structure to the every worker node, every worker node 1, worker node 2, and so this set data structure will come here, and we have a this partition of this big table, we have partition of this big table. Now executor can access this partition of this big table also, and this broadcast variable, this set, and they can use any, they can, and then Spark can apply any transformation, or Spark can do any join, everything. Spark can do whatever they want to do. Okay, so that's the concept of Spark broadcast variable. You can read about broadcast variable more in some articles. That is the main logic. So this is the mutable data structure. We'll start data structure which is cache in nodes memory. So Spark will try to directly directly send the copy of this variable inside the worker node. It will not load. So we will load big table, but we will not load small table. In case of broadcast join, we will Spark will assign, Spark will send copy of this broadcast variable, or you can say copy of this small data set to every worker node. You should remember this. When you are loading means we are partitioning. For small table we should not partition. Okay, we have to send. Spark will try to send the copy of the small data to every worker node. Okay, so that is the logic. Now we'll see how to write code, because that's the main part of this video. So I will give you one scenario, and then I will try to explain. Okay, by one example we will try to solve the coding question. Okay, now start writing code. So first I will show you the dataset. So the dataset is this. So you can see this is the customer order, sorry, big data. It means this is the big table. In this dataset, you can see we have this first column is the keyword, and this is the advertisement category. Like, so one guy is trying to sell their sell their courses in their website, and for that reason that guy is advertising, like that guy is doing some SEO optimization, some Reddit thing, and also it is posting some advertisement in Reddit, also in Facebook. So if anyone search in internet Pysaprk training with live access, it will try to so Google will try to show the website of that guy. Okay, so that's why he is spending money to Google AdSense. Also, he is spending money on Reddit to advertise. Also in Facebook. So this is the keyword for which that guy is spending money. Okay, this is the keyword. Okay, this is the category where he is spending money. Some SEO keyword are Reddit and Facebook. This is the three category in this data set have. So in three categories, he is spending money to advertise. And this is the currency like US dollar there. So he is spending on USD dollar and US dollar. And this is the cost, total cost to advertise this string. Pysaprk training with live access, we are spending this money. To advertise Coursera Big Data Analytics, we are spending this amount money. To Pysaprk keyword, we are spending this amount of money. Okay, so this is the keyword. Okay, now what you have to find for every keyword how much total money you are spending. You can like what our criteria is. We have to find for total Pysaprk keyword total how much money we spend, because here in Pysaprk we are spending 12. For here also for Pysaprk we are spending 590.94. So we have to find total money spent on this Pysaprk keyword, total money spent on this Python keyword, like this we have to find. Okay, so that is our requirement. So I will show you the code now. So now you can see we are trying to import Spark context here. Okay, now what we are trying to say, we are trying to import the system.input. Okay, this is for if I try to if we will try to hold our code. I already explained this thing before in my previous videos. You can check those videos. Now we are getting Spark context and giving local star broadcast. Job name is the broadcast is job name. Broadcast is the job name, and this is saying we can use all CPU code. This is the local star, means we can use CPU, can use all CPU, like Spark job can use all CPU code. And we are setting we are setting log info. I will here change the log info warning, or if I get some error, if I get some error, then I will see that. Okay, okay, that's it. In this case, we are trying to load the big data file, big data CSV from the path. It means it will try to load the big file. Okay, big table. So this is our data set, and this is the name of the data set. You can see this is the big data.csv. We are trying to load that big data.csv, and after loading, what we are trying to do, we are trying to split it. Okay, we are using lambda function, and we are trying to, because see, we want total cost for every keyword. Total cost for each keyword, for specific keyword how much total money you are spending. To 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 do this calculation, we need only this column, first column and third column. These two columns is useless for our use case. So I need only this and first and third column. That's why what we're doing, we are creating on we are using map transformation and passing lambda. We are creating on lambda function, and we are saying that so this X will try to read every record from this data set. Okay, from this data set, and it will try to split it, because this everything will be in a list. When you are reading a file, this identity will hold every row as a string format. Okay, inside a list, this thing will be in a string format. Okay, so that's why we are doing x dot split and x dot split, and separator is a and delimiter is a comma. Okay, because this is a CSV file as well, so it will be in a string format, and this separation will be learning Python comma SU keyword comma USD comma 34.982, like this it will become here. That's why we are trying to splitting using comma separator. Okay, or delimiter, what do you want to say. And again, so we want only we want zeroth index. Here also I want third index, and we are creating tuple from this RDD. Okay, so after getting tuple, we will RDD2 will hold data like this. So now we will RDD2 has data like this: Pysaprk, comma 12, Pysaprk training with x live axis is this. You can I think you can, as you can imagine how it is coming. Okay, otherwise you can print those. We can print also. I will show you later that one. So, okay, so RDD2 has data like this. Now what I want to do? I want to calculate the total money spending on this particular QR. Okay, but to do this, I need to do some transformation. So here I am doing. I am to trying. Here I am trying to do. I am trying to swap things. Okay, I am trying to that. I am passing lambda function, and I am doing. I need this value into first. I want to this cost in my first zeroth index, and this Pysaprk into first and sorry, first index. Why I am doing it, you will be able to understand later. So again I am doing swapping here. So I am swapping here. See, I want 59.94 first index, and this thing in my second index. So that for that reason I am using a lambda function. Okay. So now RDD3 is holding data like this. Okay. So this is the first digit, the cost, and this is the our string like this. Now what I am to do that I want to I want like this, because from here I want 59.4 dot 5 spark 59.4 59.94.94 equal to comma 20. I want data like this. To do this I have to use flat map values. So flat map values will what will do, it will try to take these values of this from this pair, and will try to split it, try to flatten it. It will take one input and it will give multiple outputs. Okay, so that's why I using flatman values lambda function, passing the each record, each tuple, and we are trying to splitting. So it will take lambda value, like flatman values will take this tuple, because it is values. It will from here from there it will filter out this. This is the value. It will, because we are taking key, we are applying this flatman values on key value pair. So x will take these values. X will take this, and this it will try to split it as per space, because you can see here in this string we have a space. If between each word we have a some spaces, so it will try to split according to that space. Okay, now this we are getting this. So now if I do using flatman values, we will get value like this. RDD4 map, RD5 to RDD4 to map, this is the thing. Now we are getting this like this. Pysaprk 12. Now what I will do, now again I will try to swap. Now I have this cost in my first index, zeroth index, and Pysaprk on the first index. What I want how much money we are spending on Pysaprk keyword. That's why we are swapping it. We are swapping it again. Now this Pysaprk will come here, and this 12 will come here. This Pysaprk will come here. I want to swap again. And one thing we are doing, we are converting this cost, because here it is it is the type of this 12 is string. I want to convert to into float, because I have to add it. So that's why I am using float function, and I was swapping it using lambda function. So now I will get output like this. Okay, now what I will do, I will use reduce by key to sum all values of same key. So we are grouping it and we are calculating it. You can see now if I use reduce by key, I have the value like Pysaprk. So it will try to, if I use reduce by key, it will try to add the values of the same key. Okay, now it will try to add the 12 plus 59.94, and it will try to give the output. Here you can use group by key also, but reduce by key is optimized when when you want to minimize the data shuffling, you should use reduce by key because it is the optimized version. You can use group by key also. It will also give the same output, but internally reduce by key is much more efficient. So if I run this, okay, we are getting error because this folder is already exist. So that's why I have to give another folder name. And this, is done. If I go here, output 1, this part 100, if I go there, you can see we are getting total value. Like for this keyword, we are spending total 85 value, 85 point this much of dollar. For in, we are spending $1,680. Okay. Lot of money spending for like for garbage value. Okay. If I come here, if I open another partition 0, partition 1, for Pysaprk we are spending $12. For Pysaprk we are doing this because the spelling mistake is there. SAPRK, SPRK. Okay, that's why we are getting. So for Pysaprk total keyword we are using $450. Now observe one scenario. Observe one corner case here. So see for Pysaprk we are spending $450 because we want to sell Pysaprk related big data related course. But you can see here for inward we are spending $161,680. That is not making sense. Okay, so if you can see also for each we are spending $51.22 for week like this. Some useless word is there in our output. So what I want to do that I want to remove this useless word like in, each, like this, sc, like this useless word I want to remove from this out. I want to filter out this useless word from my output. Okay, so how we can do this? To do this we will use broadcast variable. Okay, so I already told you this is my big table, and now where is my small table? Small is the small data set is this is the big data set, this is the small data set. If I open this small data set, you can see in this data set I noted down some useless word which is not making sense in my output. I want to discard this type of keyword from my output because you can search here in is there. So I added in as a useless word. So in is there here in my this TXT data set. This is a small data set. If you see the partition 0 of my output, we can see we have this in. For in I am spending $168,000. I don't want I don't want to include this type of record in my partitions and in my output. How we can filter this type of useless word from my output? To do this, we will use broadcast variable concept. We will try to broadcast this variable to work on node and try to use filter and to filter out this useless word from our output, main output. To do this, what we'll do? We'll key down function here. Okay. Let them. Now we can use this. So def. Do def we can do now. Okay, def useless. Word. Here we'll try to read. So here we'll do file equal to using open function. We'll try to read open. our our useless.txt. So when this this you are doing. Now what we'll do, we have to create one data structure from this data set, from this txt file. That's why I am creating a set data structure, set d. So I'm creating set data structure. Why set data structure? Because you can see if you go my users.txt, each you can see each here. You can see also I can what I can say, you can see in here, also in here. So that in this data set some duplicate keyword is there. So I want to, like, I don't want to send duplicate keys into worker nodes memory via using broadcast variable, because I want to minimize the size of our broadcast variable so that it can fit into uh, worker nodes memory. Because if I send them duplicates data set keyword using my broadcast variable, that is not making any sense, because we want to filter out the keyword from our main output. If I get only one, if I have, we just only want one keyword in this data set. Using this one keyword we can filter out. Okay, we don't want any duplicate keywords. So that's why I am creating data structure. And now I will try to traverse the file what I read and try to set the dot add. We'll add this line. Okay, now we'll try to return this set d, because I already told you what is the broadcast variable. Broadcast variable is a mutable data structure which is cached in worker nodes memory. Okay, so that's why we are getting one data structure here. Now we have to broadcast it. How we can broadcast it? To broadcast it we have to do like this: broadcast val equal to sc dot broadcast, and we have to call this function. If I call this function, it will try to return set d. Set d means data set on data structure, and the Spark driver will send this set d variable to all worker nodes. So you are diagramming also in all worker node. Okay, we'll try to say all worker node. Now it is done. Now, so we will able to broadcast this set d to all worker node. Now I have to use it. Now I have to filter out. How we can filter out? Okay. To do this, what I have to do? Before doing reduce by key, I have to create another RDT. RDT 6 equal to, sorry, final RDT. Like I will give some RDT name. Then RDT 5. So I want to filter out useless word from my RDT. To do this, I have to use filter transformation. Okay. Now I will use filter transformation. Now I use lambda function, lambda x. So lambda x means it will try to read this tuple. Okay, it will try to read every tuple from this list. Now what we will do, we will check if x0 means this first keyword, this zeroth index, this is my keyword for which we are accounting total money. If the x0 not in, if it is not in what, not in this broadcast dot value. So we are saying if this Pysaprk or some major words is not in my useless word list, then we can include that word to our final identity. Let's think. Let's say. I'll give one example. Pysaprk. Pysaprk. We are saying x0 means Pysaprk. It will try to read. It will try to read this data set. This tuple. It will fetch 0th index. So x0 means this Pysaprk. Not in broadcast.val. Broadcast.val means this data set. Useless word.txt. This data set. Now we'll search each Pysaprk is present in my useless data set. No, it is not there. I cannot find Pysaprk. So it is not there. That means it will return true. So this condition will return true. This condition will return true. When it is returning true, filter will add this Pysaprk keyword in my final identity. Now let's think for each. Let's take each keyword. Now each lambda will read this tuple and it will fetch the 0th index. So each is x0 means each not in broadcast value. Now I will search each is present in broadcast value or not. So if you search each here, it is present. We search each. See, this present is. See, you can see each is present in this dataset in useless word dataset. Now when you are saying each not in broadcast value, it will return false because it is present. So it will return false. False means filter will not add filter will not include this each keyword in my final identity. So that is the concept. Now if I try to, now I am using, now I have to group by it on top of this final identity. Now I am doing identity dot field is by key, and we are passing lambda function to some to calculate value of same key. Okay, it will try to sum sum the all values of same key. Okay, now what are doing, we are using this action we are using this save as text file action, where you are trying to store output in a folder. Now this is my folder name, output 12 is a folder name. Inside this path we are getting this output 12 folder. Every time you have to give new folder name, because if you are using like, if you are, so if you have a output one folder in your directory, now again you are running this code using this output one, it will throw error because it will try to create this output one folder, but it will not able to create because it is already exist. So you have to pass every time new folder name here. Now if I run this, okay, some coding error is there for line in. Sorry for this. Now if I run this, okay, come here. Okay, it is done. Now if you go output 12 folder, okay, this is the partitions. I'll open the partitions, notepad 00. So close this old partitions. Let me close this old partition. It is also close this partition. I'll open this, this. Okay, now we can see. Now we can see we are getting only useful keyword. Okay. Now if I let me go there, useless word. Now let me search if 2 is there. 2, because you can see 2 2 in this my data set. In this it is 2 is there in my output. 2 is not there. It is some home to something. It is not there. 2 is not there. Okay. I'll come also in part 0. 2 is not there. 2 is not there. 2 is not there. Okay. Now I'll search another thing. Is with is there? Because if I copy here, if I come to my CSV dataset, if I search here I have with. I have with. You can see and all. So Spark Python with live access. This you can see with keyword is present in my big table data in big data CSV data set. This is my big table. I don't want to include this with keyword in my final output. That's why I include this with keyword as a useless word in this useless word.txt file. Now I will search in my output in partitions is with each present or not. It should not be. It should not present here. With is not there. Cannot find with. You can see. You can see also. You can see with is not there again. You can by mistake maybe some spaces that's why is included, but it should not be there. Okay, that's it in this video. Now I'll search for another example. If there is some space issue, some spelling mistake, then it will include. Otherwise, it will not include. Now I will search hash. Hash is included in my this data set. Now I will search here. Search here hash. It is not there. Okay, it is not there. Okay, it is not there. It is not there. Okay, it is not there. Hash is not there. So that's it in this video. So that's how you can solve this question. Let me check. Any is there. Any is there. It is not there. Any less. So actually what we are doing in the code, we are checking x0 not in this broadcast value. Okay, it means if it is not there, it will run true, and filter will add that the tuple in this duty. Now I will give you an example. I will add the Pysaprk here. Okay. Now in useless.txt I will use the Pysaprk. Okay, Pysaprk keyword. Okay, Pysaprk keyword. Okay, now I will again run this. Close everything. So if I add Pysaprk word in my useless word, it should not be come. It should not come in my output. So now I will try to run this code again. Run broadcast. It will throw me error because I have to change the folder name. I will give 112. Save. Again I will run this. Let me delete all those folder. All those folder. Now I will run this. It's done. I will go to this output on folder. Come here. Now I will search Pysaprk keyword is there or not. Pysaprk cannot find because I initially it is there. Now it is not there. Now I will open another partition. It should not be there. It should not be there, but it is including. I don't know why, but it should not be there. Okay. So if you able to solve this problem, why it is adding? It should not be adding because we are using this concept. If x0 not in broadcast variable, that time if x0 is present, it will try to return false, and it should not add that value, but somehow it is adding. I don't know why. If I have time I will try to debug, but that's how you can do. Okay, so main concept is how you can broadcast here. So using this variable, using sc.broadcast, you can broadcast thing. After broadcasting, you can use this broadcast variable for your join, for your transformation. Okay, if I found why this bug is there in my system, code. I'll try to find out and try to figure out and try to give a solution in my next video. That's it in this video. So that's how you can solve one problem. Okay. So actually here we are here actually here in this video what we are trying to do, that we are creating a broadcast variable and we are trying to send this broadcast variable to every worker node. Then we are doing some filter operation here, or you can filter option transformation. You can do join also, and you can join two data frame. Okay, you can broadcast one data frame, then you can join with a big data frame with small data frame. So those things I'll do later. So that's it in this video. Here you're trying to learn. Here we learned how to create a broadcast variable, how to apply some transformation on broadcast variable, and how to, that's it, and what is the broadcast variable. So that's it in this video. I hope you are able to understand about this broadcast variable. And if I find out the fix of for this code, I'll I'll create another video. Okay. Thank you all for watching the video. Bye.